Hey everybody, this is Alex Merced from Alex Merced Coder, and welcome to day number 3 of 100 days of Rust and Go. And today what I want to do is I want to focus on how to sort of declare and assign variables in both of these languages, because there are some nuances that are kind of important. Okay, so first, as usual, we'll start with Go. Okay, now with Go, assigning a variable is probably as straightforward as you think it would be. You declare a name. Okay, so we'll just say num. Okay, and then you say equals. Now I've already kind of made a syntactical error, but if I remember right, do I put the int? Yeah, num int equals 1. There we go. Now we're good. So when you use just an equal sign to declare a variable, and actually I need to use the keyword var. Okay, so use var to say, hey, I'm declaring a new variable. Num is the name of the variable, and I'm typing it as an integer. There we go. Okay, I've declared a variable. You have to type it if you're using the equal sign. Okay, and you have to use the word var if you're declaring in this way. And that's how you have to declare it if you're outside of the main function. Okay, inside the main function, you're going to have another option. Okay, but then if I go here, I can inject num, and the reason is this has to know anything outside the main function. The compiler needs to know at compile time, because it's not assumed that it's happening at runtime. If it's inside the main function, it's assuming, okay, we're going to figure this out at runtime, but we can still kind of well, you'll see in a second. Okay, so now let's go back to the Go terminal. And see, it says hello 1. Okay, I saved the variable in there. Pretty straightforward, right? Okay, not bad at all. And there's a lot of different types, so you can actually get specific with your integers and be like int 8 and 32. Like I think I'm pretty sure I could just do int 8 and I get uint1. I think I can do uint 8 and that still works. Now what does that mean? Okay, the number is the number of bits. Okay, that's the amount of memory that's saved, that's allocated to save the number. So the bigger the number, the more bits you're going to need. Okay, so I think it goes like 8, 16, 32. Okay, if you don't declare a number, it's just going to default to 32. But the idea is that if you want to write a faster program and you know, like, hey, this number is only going to be so large, you can kind of Google, like, what is the maximum number in an 8-bit integer. So I can be like here, like max number in an 8-bit integer, 256. Okay, 256. Cool. Okay, this is kind of part of the reason why when you do hex codes, I think like those are 208-bit numbers. So it's basically like, or like the RGB scale, where it's like RGB is like 0 to 255. So there's like 3 8-bit numbers representing red, green, blue. So yeah, and then again, let's say maximum 16-bit number. Okay, 65,043. This is why, like, if you're setting up a port on a web server, the highest number you could set is like 60, that number. And then it's the highest 32-bit integer. Okay, there you go. And then this is basically, once you start being bigger than that, you start looking at other things. Let's take a look at 64-bit out of curiosity. There we go. And the reason why that matters, and this is like what was a big deal when we went from like 8-bit NES to 16-bit Nintendo, because you had more values you could work with, which means your code could be more complex. Okay, but again, you can determine like what number do you need. So that's what the 8 stands for. Now the U stands for unsigned. Okay, so if you don't put a U, then it's signed. Signed just means, can it be positive, negative? That's literally what it means. Okay, it always sounds a lot more fancy, but it really just means if it's signed, it can have a sign, like a negative sign. Okay, so in that case, it has to allocate space for that negative sign. So that means you can't have as high a number in a signed integer, because you have to allocate memory for holding the sign, versus a unsigned integer, which can hold a higher number, but only positive, because there's no sign, so it's just an absolute number. So it just depends on what your needs are. If you know it's never going to be negative, then you would prefer an unsigned integer, okay? Because an unsigned integer is going to be better. Okay. So that's how you declare a variable, okay? Normally. But now, if I'm inside the main function, I can do something pretty cool. So let's say I can just declare a variable name. I don't think I have to use the keyword var. And then I use the Walrus operator. The Walrus operator looks like this. It's just basically like an walrus eyes with the tusks. Okay, they have this in Python. I think it does something else in Python. Num2 equals, and then you say, hey, I want it to equal 45. Okay? And then that's fine. This means that, hey, instead of me typing it, I don't have to declare the type because it's going to imply the type based on the value on the other side. But I have to assign it a value. And once I assign it a value, that's the type of that variable. That variable's type does not change. Okay, so that's now going to be a integer. It's going to assume a 32-bit integer because, you know, it's 32-bit signed integer because that's like sort of like the safest assumption. Okay, that gives the most flexibility depending on your usage. Again, the idea is like the more detailed you get, the more memory you can save, but also the more work it is. Okay, so you know, if you really go out of your way to type things in Go and write and lean into the tools that the compiler gives you to tell it how to compile, Go can be pretty fast, and I think you could actually write code that's just as fast as Rust. But you know, you have to kind of really get intimate with sort of like what's going on in the code and what how the Go compiler works, because a lot of those decisions are not made by you. They're going to be made at the compile time. So it's going to be based on how you write your code and structure your code and how efficient that compiler is going to be. But also just makes for a much more pleasant developing experience versus I'm not worrying about semicolons. Like this makes declaring variables a lot easier. For a lot of situations, this is just like awesome. Okay. And again, you know, like there's not much in the way of extra like symbols. As you'll see in Rust, we're going to throw some extra things. But that's how you declare variables. Pretty straightforward, right? Now, if I wanted this variable to be available to other files, again, it's going to be uppercase. So we haven't gotten to multiple files yet, but just so you're always aware, there is like this issue with casing in Go. So you have to be aware of that. Now, in Rust, let's head over to Rust. Okay, so let me switch over to my Rust terminal. Okay, declaring variables in here. Let's see here, if I remember correctly. I think you just type it. It's going to be more like C and C++ where you just put the type name. So I think it's just, I would just say like something like, actually no, not even. Okay, let's peek. Let's peek. Okay, variable bindings in Rust. Oh, let, you can use let. Okay, let. Okay, so you would just say, hey, let num, and then here's where you would type it. Now, in this case, if it's a integer, it's I. So I8, I16, I32. And if it was unsigned, it would be just U. Now that I like, because it's like they're like just a little bit less typing, but they're not necessarily as obvious name-wise. So like to know that U32 means an unsigned 32-bit integer. Okay, but once you know sort of like what the bits and the signed unsigned means, it's a lot easier to think through like when I would need which. Okay, so I can do here, let's just do an unsigned 8-bit integer, U8, and then equals 45. And then I'm going to say over here, I can then now use the variable and say, hey, num. Okay, but here's the thing. In Rust, they are pretty strict about having semicolons. So I do need semicolons at the end of each line. Okay, now if I run the code, see I get hello world 45. Okay, I don't have to type the number. Okay, it will, if I assign it a if I don't assign it a value, then I have to. But if I assign it a value, then it'll just base it again. It'll dynamically say, okay, well, it's a 45. I'm going to use a 32-bit signed integer. Okay, I think is the default. Okay, so in that case, this will still work, and there you go. So it's just let. I don't think there's like really much more else to that in Rust. Okay. Cool. Yeah, so that's pretty much it. And again, we inject that by using these curly brackets, and yeah, that's all there is to declaring a variable. Oh, wait, there is another really super important detail. Okay, I can't reassign, like in Go, I can reassign these variables. Okay, these variables are all, they're not constant, which begs the question, how do you do a constant variable in Go? We'll come back and look at that. But in Rust, it's automatically a constant. So if I were to go on the next line and say num equals 30, okay, on the very next line, I'm going to get an error. Okay, so you cannot assign twice to an immutable variable. So they're immutable, meaning unchangeable by default. Okay, you're just basically binding this value to this variable. So if I want it to be mutable, to be changeable, I have to do let mute, meaning let it be mutable. Okay, and then, well, it gives me a warning, but otherwise it's like, yeah, you can do that. Okay, now it'll give you warnings if like you do pointless things. This is one of my favorite things about Rust, that the compiler does give you a lot of information. Like when you run into an error, once you learn how to read the errors, it usually is pretty clear about what you need to do to fix the problem. Which helps make up for some of the frustration of getting so many errors and warnings. Because again, it's such a strictly typed language. But see, it's telling me like, you know, this 45, you never do anything with it. So we assign the value. The program will run fine, but you're doing this unnecessary thing. Do you really want to do that? Okay, and so it gives us like a pretty detailed warning. Okay, so that's pretty cool. So, but again, the big thing to remember is like let is immutable, let mute is mutable. That's in Rust. Now let's just check, how do we do a constant variable in Go? Constant variable in Go. Constants. Oh, okay, we just declare with a const, just like JavaScript. Okay, I should have reasoned that. Okay, so yeah, you would just declare const num3 equals 8, no semicolons, and then if I try to reassign it, so if I go over here and I do num3 equals 5, that should cause an error. Okay, and that's gonna have to be typed. So okay, and see, I get the error. The Go errors are not going to necessarily be quite as verbose as the Rust errors. They're not bad though. I like the Go errors. They're not quite this sort of mishmash of information. This takes a while to get used to at first, but once you get used to this, you'll see like this is really nice because it does give you just a lot of detail to really understand. So it's really kind of explaining you why that is a problem, or what could be the problem if there is a problem. And it tells you, hey, it's giving you this warning because this is on. Okay, this macro that says, hey, warn you about unused assignments is on. So if you really don't want to get this warning, you can turn that off. So it's pretty cool. I like that a lot. Cool. Okay, so I think you guys understand the idea of like, how do I assign a variable, a value to a variable. And we talked about the different types of integers, so now you know the difference between a signed and unsigned integer, and 8-bit and 16-bit and 32-bit. So hopefully that's a good day's work. I'll see you all in the next video. Have a great day and enjoy.